Hello everyone, here's Smriti. Welcome to Physics Fact.
In previous class, we discussed that angle of prism and angle of deviation. What is angle of prism? That angle of prism A equals to sum of R1 plus R2. Here, this one is R1 and this one is R2 and this one is the angle of prism. Then here this one is the angle of incidence I and this one is the emergence angle I prime. Yes? And here this one is the actual path of the incident ray, but here this one is the emergent ray. That means that emergent ray is deviate. Okay, emergent ray deviate. So this one is the angle of deviation, we written as delta. Okay, so what is the deviation angle? What is the angle of deviation? That angle of deviation is depends on angle of incidence plus angle of emergence minus angle of prism. Okay, student, that equation is elaborately explained in previous lecture. You go to the description box, your link is already given. You go through the link and watch the video so that you better understand this topic. Now, here we also got that angle delta, that is angle of deviation and angle of prism. The sum of angle of deviation and angle of prism, that is equals to I plus I prime. You remember this equation. Okay, student. Now, when we consider about general prism, at that case, this equation is applicable. Okay, that means delta is depends on angle of incident, angle of emergence and angle of prism. Now go to that angle of deviation through thin prism. When we consider about thin prism, that means that here this angle is very less. That angle of prism is very less. How many factor this one less? That angle of prism is less than 10 degree. At that case, prism is called as thin prism. Okay, that angle of prism is less than 10 degree. In this case, what is the value of angle of deviation? We determine it. Okay. So first, we take the refractive index of prism. Refractive index of this prism. Take as this one is mu. Rays passes from a rarer to denser medium. Yes. So take as that rarer medium mu1 and denser medium refractive index take as mu2, that mu2 equals to mu. And in air medium, that refractive index of air medium mu1 equals to 1. We know that according to Snell's law, here students, refractive index of prism take as mu. According to Snell's law, we know that sin I by sin R1. Here sin I by sin R1 equals to mu2 by mu1. Okay. Mu2, that means refractive index of the prism, take as mu. And mu1, that is refractive index of air medium, take as 1. And because of that angle of incident, angle of refraction is very less. So, sin I is equivalent to I and sin R1 is equivalent to R1. So, put here I by R1 is equals to mu. What is I? I equals to mu R1 for first refracting surface. Okay, for first refracting test. Similarly, for second refracting case, that I prime is equals to mu R2. So that angle delta is equals to I plus I prime minus A, angle of prism. In the case of I and I prime, we put these values. Okay, so mu R1 plus mu R2 minus angle of prism. Take common mu, then here R1 plus R2 minus A. Then student, here R1 plus R2, that means, that is, we know that R1 plus R2, that is angle A. So mu into angle A minus angle A. Take common angle A, this one equals equals to mu minus 1. That means angle delta is equals to A into mu minus 1, where A is the angle of prism, is the refractive index. Okay, that means as we increase the angle of prism, the angle of deviation is also increases. Or as we increase the refractive index of prism, at that case also angle of deviation increases. As angle of prism increase, angle of deviation increase. As refractive index of prism increase, angle of deviation is also increase. Okay, students. But as in case of thin prism, delta is depends on angle of prism and refractive index, but independent on okay, angle of incidence and angle of emergence. Clear, students? Okay. But in general case, delta is I plus I prime minus A, this formula. But for thin prism case, delta equals to mu minus 1 into A. Okay, student? On the basis of this concept, we go to solve these examples. Okay. So first one, students, a ray of light passes through an equilateral glass prism such that I is equals to E. That means angle of incidence is equals to angle of emergence. Angle of incidence is equals to angle of emergence. Equilateral triangle, that means angle of prism, that is 60 degree. Also, the angle of incidence is 3 by 4th of angle of prism. That I is equals to 3 by 4th of angle of prism. Here, calculate the angle of deviation and calculate the speed of light in prism. So students, here what is the value of I? That is 3 by 4th into angle of prism, that is 60 degree. Simplify this one, we got that 45 degree. Yes, we know that students, delta equals to angle I, angle of incidence plus angle of emergence minus angle of prism. So here we write the statement, the equation, that I prime minus A. Here this one is angle of incidence, this one is angle of emergence, and this one is angle of prism. So here in question, angle of emergence is denoted by E. So here write E. Okay. Then I equals to 45 degree. I is equals to E. So this one also 45 degree minus A, that is 60 degree. Then simplify this one, 90 minus 60. That means angle of deviation, that is 90 minus 60, that is 30 degree. Okay. Calculate the speed of light in prism. So, given that mu equals to 2, that means refractive index of prism, that is given, that is equals to 2. We know the student, mu equals to C by V. So what is V? V equals to C by mu. So what is C? That is velocity of light, that is 3 into 10 to the power 8 meter per second, divided by mu. Mu equals to 2. Simplify this one. So V equals to 1.5 into 10 to the power 8 meter per second. The velocity of light in prism, that is 1.5 into 10 to the power 8 meter per second. Okay, students? Next, go to the second example. A thin prism of refracting angle of prism is 2 degree. That means angle of prism, that is 2 degree. Thin prism, that means angle of prism is less than 10 degree. You are given that angle of prism is 2 degree. And deviate an incident ray through an angle 1 degree. Means incident ray deviated by 1 degree. That means angle of deviation, that is 1 degree. Find the value of refractive index of the prism. We know that students, in case of thin prism, angle delta equals to mu minus 1 into angle of prism. Okay, then what is mu? A go to this side, angle of deviation by angle of prism equals to mu minus 1. Then what is mu? Mu equals to angle of deviation delta divided by angle of prism plus 1. Okay, next, mu equals to angle of deviation, that is 1, angle of prism, that is 2 plus 1. Then mu equals to 1 plus 2 by 2. That means mu is equals to 3 by 2 or is equals to 1.5. students? Deviation angle is represented by delta. Like minimum deviation is represented by del m. Then what are the condition of minimum deviation? Okay, first one student, here we plot graph. Okay, here we plot graph. Take as angle of incidence along x-axis and angle of deviation along y-axis. And for 10 degree, when angle of incidence is 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 60 degree, like this, what is the angle of deviation? Okay, we take that angle of incidence for different case, and for this different case of angle of incidence, what is the angle of deviation? We first do the experiment and put the value in this graph. Then here what we got? As we know that delta is depends on angle of prism and refractive index of prism. That means as we increase angle of prism, deviation angle is also increases. As we increase the refractive index of prism, also deviation angle increases. But what happens when we increase the angle of incidence? Clear? When we increase angle of incidence, okay, then as angle of incidence increases, angle of deviation decreases. For 10 degree, take as this one is the angle of deviation. For 20 degree, this value is decreased. For 30 degree, this value is further decreases. For 40 degree, this value is further decreases. Okay, then for a particular point, this value is very less. Okay, for a particular point, this value is very less. Then further if we increase the angle of incidence, then angle of deviation further gradually increases. For 60 degree increase, for 70 degree increase, for 80 degree also increase. When we join that graph like this, okay, that means for particular one value, for a particular value, we got minimum deviation. For particular value, we got minimum deviation. Okay. First, as we increase the angle of incidence, angle of deviation gradually decreases. For a certain value, okay, for a certain value of angle of incidence, that deviation is very less, and that is the minimum deviation. Then further, if we increase the angle of incidence, angle of deviation is also gradually increases. Okay, student, and the graph is like this. So, इस ग्राफ से हमें क्या पता चलता है? For a particular angle of incidence, we got minimum deviation. सिर्फ एक एंगल ऑफ इंसिडेंस के लिए हम एक पर्टिकुलर डेविएशन एंगल पाएंगे. हाँ? देखो यहाँ पे देखो, here take us this deviation angle, take us this one is 40 degree, and this deviation is occur for this angle of incidence, also for this angle of incidence. Okay ना? That means for हम 10 डिग्री पे डेविएशन एंगल 40 डिग्री पा गए, और फिर 60 डिग्री इंसिडेंट पे भी डेविएशन 40 डिग्री पा गए. पर ये जो डेविएशन, मिनिमम डेविएशन था, ये सिर्फ और सिर्फ ओनली एक एंगल ऑफ इंसिडेंट पर ही हमें एंगल ऑफ मिनिमम डेविएशन मिलेगा. समझ आया? दैट मींस फॉर ए पर्टिकुलर प्रिज्म, for particular angle of incident, we got minimum deviation. Only at one and only angle of incidence, we got minimum deviation. Clear, students? Then, when the deviation is minimum deviation means what? The deviation is minimum. Okay. deviation is minimum, what are the case? What are the conditions? Okay, so what are the conditions? Now first one, that the angle of incidence and angle of emergence. Okay, angle of incidence and angle of emergence. The two are equal to each other. Here this one is the angle of incidence and this one is the angle of emergence. The two are equal to each other. This one is first condition. Then second one, as angle of incidence and angle of emergence equal, here R1 and this angle is R2. R1 and R2 is also equal to each other. This one is the second condition. And third condition, and that is the basic important condition, that refracted ray QR, is parallel to this. Refracted ray QR parallel to base of the prism. Clear, students? Okay. Next, we discuss prism formula. Prism formula. That means here we relate refractive index of prism with angle of prism and deviation angle. Also, here we determine refractive index of prism. So, first one, student, we take that refractive index of prism, that is mu. We know that angle of prism, that is angle A, and deviation angle delta. Also, we know that these two formula, that angle of prism plus angle of deviation, that is angle of incidence plus angle of emergence, and angle of prism, that is angle R1 plus angle R2. For minimum deviation, delta is equals to delta m, and we know that I is equals to I prime. So angle A plus angle, in the value of delta we put del m because of minimum deviation, that is equals to I plus I prime, that is same. So I plus I plus I, that means 2I. 2I is equals to angle A plus angle delta m. So what is I? That I equals to angle A plus angle delta m divided by 2. Clear, students? Now, we also know that another condition, that R1 is equals to R2. We take that R1 equals to R2, take as that is R. Okay. So, we know that angle of prism A is equals to angle R1 plus angle R2. In the case of R1, R2, we put that R. That means 2R is equals to A. Then what is R? R equals to angle A by 2. Okay. Refractive index of prism, that is equals to mu. And according to Snell's law, we know that mu equals to sin I by sin R. In the value of I and R, we put the value sin I, that is equals to angle A plus delta m by 2 divided by sin R, that is angle A by 2. Sin angle A divided by 2. That means refractive index of prism mu equals to sin angle A plus delta m by 2 divided by sin angle A by 2. You clear, students? That means here we got that refractive index of prism depends on mu depends on angle of the prism and deviation angle of the prism. Okay, so in this condition we got that refractive index of prism is depends on angle of prism and angle of minimum deviation. You clear, students? Calculate the angle of minimum deviation for an equilateral triangular prism of refractive index mu equals to root 3. That means, student, here we calculate angle of minimum deviation, that means delta m. Then here the prism, that is equilateral triangular prism, that means angle of prism, that is 60 degree, and refractive index mu equals to root 3. Okay, we know that from prism formula, okay, that mu equals to sin a plus delta m by 2 by sin a by 2. Yes, student. Just we discuss about it. Then mu equals to root 3 equals to sin a, that is 60 degrees. 60 degree plus delta m by 2 divided by sin 60 degree by 2. In the case of a, we put the value. Then this one equals to sin 60 degree by 2, that is sin 30. Sin 30, that is equals to half. Okay, sin 60 degree plus delta m by 2 divided by half equals to root 3. Half go to this side. Okay. Then root 3 into half is equals to sin 60 degree plus delta m by 2. Then here that is root 3 into half. That means root 3 by 2. Okay. Then sin 60 degree equals to root 3 by 2. In the case of root 3 by 2, we written as sin 60. Okay. Sin 60 equals to sin 60 degree plus del m by 2. Sin cancel. Then 60 degree is equals to 60 degree plus delta m by 2. 2 go to this side. 120. Then equals to 60 degree plus delta m. Then what is del m? Del m equals to 120 degree minus 60 degree. Okay, that means del m is equals to 60 degree. Clear, students? Then this one is a very important question. Students, in this question, show that the angle of minimum deviation produced by thin prism is reduced to 1/4 when it is immersed in water. That means, students, तुम लोग सोचोगे कि यहाँ पे क्वेश्चन में तो एंगल ऑफ मिनिमम डेविएशन दिया गया है, तो हम ये फॉर्मूला यूज करेंगे। नहीं, यहाँ पे दिया गया है एंगल ऑफ मिनिमम डेविएशन प्रोड्यूस्ड बाय थिन प्रिज्म। थिन प्रिज्म, दैट मींस दैट फॉर्मूला that is del equals to mu minus 1 into a. You clear, students? That minimum deviation produced due to the thin prism by the thin prism. So the formula here is used, the del equals to mu minus 1 into a. Okay, then when we put the prism in glass medium, that del 1 equals to that mu, that means your refractive index of prism or refractive index of glass prism with respect to air minus 1 into angle of prism. Okay, when it is immersed in water, okay, when it is immersed in water, del 2 equals to refractive index of glass with respect to water minus 1 into angle of prism. You clear, students? Then here in question that given that refractive index of glass with respect to air, that is 3 by 2, and refractive index of glass with respect to water, that is 9 by 8. That is given. Okay, student, you put the value here. Okay, that means here this one equals to 3 by 2 minus 1 into angle of prism. Then here 9 by 8 minus 1 into angle of prism. Okay, then how we calculate? Then 3 minus 2 by 2, that is 1 by 2 into a. Then this one equals to 9 minus 8 by 8. That means 1 by 8 into a. When we take the ratio, del 2 by del 1 equals to 1 by 8 into a, 1 by 2 into a. A cancel, equals to 1 by 4. That means del 2 is equals to 1 by 4 of del 1. When prism is immersed in water, that angle of deviation is reduced by 1 by 4th of its original deviation. That means when we take that prism in air medium, this one is the angle of deviation. When we take that prism in water medium, this one is the angle of deviation. Here we got that angle of deviation is 1 by 4th of the original. Okay, I think you all clear and enjoy the lecture.